Welcome, my dear student, in our math program for secondary 3. Dear student, today we are taking your lesson in static. What's the title? Exercise on equilibrium of forces parallel and coplanar. أعزائي طلبة وطالبات الثانوية العامة، اليوم سوف نقوم بشرح تمارين على الاتزان. شرح على الاتزان القوى المتوازية والمستوية. تعالوا النهاردة نقوم بشرح بعض المسائل أو التمارين على القوى المستوية والمتوازية. فين؟ في الاتزان. Exercise on equilibrium of parallel coplanar forces. The first example. AB is a rod of length 100 centimeter and weight 10 Newton, acting at its midpoint, rest in horizontal position into supports, one of them at A and the other at a point 25 centimeter distant from B. What is the magnitude of the weight that should be subtended from the end B of the rod, so that reaction on the support nearer to this end will be 6 times its value at point A? What is the value of reaction? Then look at the solution. We have AB, uniform rod, its weight 10 Newton. We have two support at point A, at point C. The support or reaction at point C is 6 times reaction at point A. And we have weight at a distance 25 centimeter from C. Remember, dear student, we have uniform rod. What's the meaning of uniform rod? Excellent student. Its weight act at in midpoint of AB. What is the weight? 10 Newton. What is the length of AB? 100 centimeter or 1 meter. Dear student, look at the first equation of an equilibrium. R plus 6R equals 10 plus W. We find W equals 7R minus 10. This first equation of an equilibrium. We have two unknown, W and R. We need another one equation. We find moment about A. Moment about A equals 0. Therefore, look at negative 10 times 50. Why negative? Because, yes, clockwise. This motion is clockwise with negative. But 6R is positive. Why? Because anti-clockwise. The moment about A. Negative 10 times 50 equals 6R times 75. Negative W times 100 equals 0. Therefore, negative 500 plus 450R minus 7R negative 10 multiply 100 equals 0. Therefore, answer is 50. 500 equals 250R. What is the value of R? Equals 2. By substitution, in the reaction A, R equals 10. But in reaction, the reaction C, 6R, R equals 6. Then, therefore, R equals 2. 6 times 2 equals 12 Newton. Therefore, reaction at point A equals 2 Newton, but reaction at point C equals 12 Newton. From equation, we get 7 times 2 minus 10 equals 4 Newton. We find the value of W and the value of R. Look at another example. Dear student, the previous example, find the value of reaction and value of the weight of the rod. Remember, dear student, in this example, we find two equations. One of them is equation of an equilibrium. The second, we find the moment at any point equals 0 to find the unknown value. After that, by substitution in the first equation to find the value of R and W. Remember, reaction of the first point is 2. Reaction of the second point is 6 times. 6 times 2 equals 12. After that, we find the value of W by substitution R equals 2. Dear student, look at another example. AB is heavy non-uniform rod of length 140 centimeter suspended by 2 vertical strings at its. One of them at B, the other is 40 centimeter from E. If the tension in the string at B equals quarter the tension of the string or the other string, find where the weight of the rod act, and if the greatest weight suspended from A equals 12 Newton, such that the rod is still in an equilibrium. Find the weight of the rod. Look at the solution. Dear student, look at the weight is W. We have two tension. The first T, the second is quarter T. The distance between C and dx. The distance between C and B equals 100. Suppose CD equals x. Therefore, distance BD equals 100 minus x, because AB equal 140 centimeter, AC equal 40 centimeter, then CD equals 100. Let CD x, therefore BD 100 minus x. By using, look at, we find moment B equals 0. Therefore, quarter T times 100 minus x minus Tx equals 0. By using highest common factor, x equals 20 centimeter. Therefore, T2 equals 0, moment C equals 0, 112 times 40 minus W times 20 equals 0. After that, find the value of W by simplify equals 24 Newton. Look at another example. AB is rod of length 100 centimeter, weight 20 Newton, act at its midpoint, rest in horizontal position on two supports. One of them is at a distance 30 centimeter from A, and the other is a distance 20 centimeter from B. Find the magnitude of the pressure on each of the two supports. Also, find the magnitude of weight that should be subtended at B, such that the rod is about to rotate. Then find the value of the pressure on the support which is nearest to the point B, that instant. Solution. Dear student, look at AB. Its length 100 centimeter, its weight 20, act at midpoint E. We have P1, P2 is tension of C and D. Look at D at distance 20 centimeter from B. Also C at distance 30 centimeter from A. R equals 0. Therefore, B1 plus B2 negative 20 equals 0. Therefore, B1 equals 20 minus B2. This is the first equation of an equilibrium. After that, we find moment about C. MC equals 0. What you mean? B2 times distance 50 equals 20 times 20. Find the value of B2 equals 8 Newton. Why? Because 20 plus 20 equals 400. Divided 50 equals 8. After that, we find B1 by substitution about B2 equals 8. B1 equals 90 minus 8 equals what? 82 Newton. B equals 0. Therefore, the second case, B dash, when B equals 0, B dash equals W plus 20. We find moment about D equals 0. Therefore, look at 20 times 30 equals W times 20. After that, we find the value of W equal 30 Newton. After that, substitution about from 1 and 2, B dash equals W plus 20. Substitution about W equals 30. Therefore, B dash equals 50 Newton. Look at another example. Non-uniform rod ABCD rest in equilibrium horizontal into supports at B and C, such that AB equals 6 cm, CD equals 7 cm, and the point of application of the par weight divided the rod with the proportion 2:3 from the side A. It was found that if weight of magnitude 120 gram weight suspended from the end A, or if weight of magnitude 108 gram weight is suspended from the end D, then the bar in either cases is about to rotate. Find the bar weight as well as the distance between both the parts. Look at the solution. Look at AB, ABCD. Therefore, ABCD, E, W act at point E. We have two support at B and C, R and R dash. We have weight 120 act at point A. When the weight 120 is support from end A, look at the student, we find moment B equals 0, R dash equals 0, moment about B equals 0. Therefore, we find moment about B equals 0 by 120 times 6 distance between A and B, equal distance between E and B, 2x minus 6 multiply W. After that, 720 equals 2wx minus 3 inside bracket by using highest common factor 2 divided by 2. Therefore, 360 equals W times x minus 3. This equation number 1. We need another equation. Why? Because we have two unknown W and X. After that, what is the relation between W and X? W equals 360 over bracket contains x minus 3. Look at the second case, 180 act at point D, moment C equals 0. What you mean? W times distance 3x minus 7 equals 180 times 7. We have two unknown also, two equations. From 1 and 2, we get W times 3x minus 7 over W times x minus 3 equals 180 times 7 over 360. By simplify, divided each one by W to find the value of x. Therefore, and divisible by 180 right hand side. Therefore, we find the equation. The left hand side becomes 7x minus 21 equals 6x minus 14 to find the value of x. Therefore, x equals 7. After that, the distance between the two supports is BC is 22 centimeter by using x equals 7. From 1, by substitution, W equals 90 gram weight. Dear student, look at another example. AB is non-uniform rod of length 1 meter raised on two supports at C and D, where AC 20 centimeter, BD 10 centimeter. If the maximum weight suspended at A, keep the rod in an equilibrium is 5 kilogram weight, while the maximum weight suspended at B to keep it in equilibrium is 4 kilogram weight. Find the weight of the rod and the point of its action. Look at the solution. In this example is non-uniform rod. Remember, we have two types of rod, uniform rod and non-uniform rod. Uniform rod means its weight acts at midpoint, but non-uniform rod, its weight acts at any point on the rod. Dear student, look at the solution. Dear student, we have AB is a rod. We have two supports, C and D. Look at W act at point E, midpoint is W. We have 5 maximum weight at point A. We have two cases. The first case, dear student, R dash equals 0, MC, moment at point C, equal 0. If we find moment at C equals 0, R dash equals 0. After that, we find the moment about point C. We have two weights. The first 5, second W. 5 times 20, or weight 5 times distance 20 centimeter, equals W times X. Therefore, we have two unknown, W and X equals 100. This first equation. We need another equation. Look at the second case. The maximum weight for act at point B is 4. We find R1 equal 0, then moment at D equals 0. Dear student, find moment about D. We have W times distance 70 minus X equals 4 times 10. We have 70 times W minus WX equals 40. After that, we find 7W minus 100 equals 40. Why? Because the first is WX is 100. By substitution from 1 and this equation, WX equals 100. Therefore, 70W equals 140. Therefore, by divided by 70, W equals 2 kilogram weight. 2x equals 100. Therefore, x equals 50 centimeter. Remember, the first equation, 2 times x. What do you mean 2 times x? Wx is 100. The first W is 2. By substitution, about W equals 2. Therefore, 2x equals 100. Therefore, x equals 50 centimeter. Dear student, in this example, we have two unknown, W weight of the rod and the distance x. We need two equations. The first equation, we find it with an equilibrium. The second equation, we find it in moment about point 1 of the two ends. After that, by substitution, we find Wx equals what? Equals 100. We find W equals 2. Then we find by substitution about W to find the value of x equal 50 centimeter. What you mean is W act at 50 centimeter from the end. Dear student, look at another example. This example is very important. AB is a rod, length 9 centimeter and weight 50 Newton, act at midpoint rest in horizontal position on two supports. One of them is at end A and the other is at point 20 centimeter from B and carries weight of magnitude 20 Newton at point 15 centimeter from point B. Find the magnitude of the pressure on each support. Also, find the magnitude of weight that should be suspended from the end B so that the rod is about to rotate. What is the magnitude of the pressure on the board as instant? Look at the solution. Dear student, from the equilibrium, the resultant equal 0. What is the meaning of the resultant equal 0? B1 plus B2 equal 50 plus 20 equals what? Equals 7. We have equation of an equilibrium. This equation we have two unknown, pressure 1, pressure 2, P1, P2. We need another equation to find each pressure. After that, we use moment about any point. Look at moment at a point A equals 0. Therefore, look at when we find moment about A equals 0, B2 times distance between C and A equal 60 equals B 50 weight times 45. In this case, we find the value of B2. What is the value of B2? After that, we have, remember, we have, when we find moment about point A, we have three forces. The 50, the first 50, or 3 weight. The pressure P2, the weight 20. Remember, dear student, in an equilibrium, on the first equilibrium, we have B2 plus P1 equal 50 plus 20. When we find moment about A, therefore, we find the distance between B2 and A, B2 times 60. After that, equals 50, the first weight times distance 45. The second weight 20 times distance 75. In this equation, to solve or to find the value of B2, it's easy to find, divided by 10 in each term. After that, B2 equals what? 3,750 divided by 60 equals 62.5 Newton. By using substitution, B1 equals 7.5 Newton. Then the pressure of B1 act at point A is 7.5 Newton, but the pressure B2 act at point C is 62.5 Newton. Look at the second case, B dash, resultant B dash equals 0. Therefore, we find moment about C. When we find moment about C equals 0, 50 times 15 equals what? 20 times 15 plus W times 30. We find the value of W by using 750 minus 300 equals 30 W. Therefore, divisible by 30, W equals 15 Newton. After that, when result equals 0, B dash, B plus B dash equal 50 plus 20 plus W. What is the W? Is 15. Therefore, B dash equals 85 by substitution about B and W. Dear student, look at another example. AB is a non-uniform rod of length 5 cm. If weight of magnitude 2 Newton is fixed at end B and weight 7 Newton is suspended at the end A, the rod is in equilibrium horizontally at a point of distance 20 cm from A. If the weight at A is decreased to become 4.2 Newton, then the rod will be in equilibrium horizontally at a point of distance 25 cm. Find the weight of the rod and the distance between the point of weight application and the end A. Look at the solution. Dear student, look at AB is a rod, C at distance 20 cm. The distance between B and C is 45 cm. Then AB equals what? 65 cm. Let WE act at point E. The distance between B and C equals 45 cm. Suppose the distance between E and C X. Then the distance between B and E 45 minus X. Look at the student from an equilibrium. Moment about C equals 0. 2 times the distance 45 equals W times X minus 7 times 20 equals 0. Therefore, Wx equals 140 minus 90 equal 50. This equation number 1. Look at moment about D equals 0. Second case. When we find moment about D equals 0, we have 2 times 40 equals W times X minus 5 inside bracket minus 4.2 times 25. Why? Because 4.2 is clockwise, but 2 is anti-clockwise. Then this equation becomes 80 times 80 plus Wx minus 5W minus 105 equals 0. By substitution about Wx equal 50. Then 80 plus 50 minus 105 equals 5W. We find the value of W equals 5 Newton. After that, from equation 1, to find the value of X by substitution about W, therefore X equals 50 over 10 equal 5 centimeter. What you mean? X equal 5 centimeter. Then, therefore, look at W at equals 5 Newton. This is act at distance AE. What is the distance AE? Equals 25 plus 5 equal 30 centimeter. Means W or weight. The weight act at point E at a distance 30 centimeter from the point E. Dear student, by the end of the lesson, we know that exercise about equilibrium of the forces parallel and coplanar. Dear student, I am very happy to spend such time with you. Goodbye.